Hello and welcome back. In this session we just want to talk about the mutation, one of the main operators of GA. This is quite different from the mutation and crossovers. So for the crossover we just selected two different parents and then we have to try to generate two offspring with these two parents, but here is just quite different. For the mutation we just selected one population and try to change some variables or variable to our solution representation. So let's get started. Suppose that we have this solution representation. So at first we have to consider the fact that we just wanted to change one variable here. So we have to say that we just selected randomly a decision variable. Suppose that this decision variable is just selected randomly, and then we have to just change it. If this is 1, it changes to 0, and if this is a 0, it would be changed to the 1. So here we have a 1 for this selected index, and we just wanted to change it to 0. So this is a procedure that we use for the mutation. In general, if y would be index that is selected randomly, we just use this formula here. So yj would be 1 minus xj. What does that mean? It means that we just convert any binary variables to the other type of binary variable. So if we have a 1, it just changed to 0, and if we have a 0, it's just changed to. So let's just get back to our code and apply this strategy to the code. So here we just wanted to apply the mutation operators to our GA. At first it would be the same as crossover, so we have to determine the pop m as a pop that we want to just store the information to the pop of mutations. So pop m would be repmat empty pop nm and 1. So here we just started the main loop of the mutations. So it would be for I. Here we have to randomly selected a pop here. So this code can be used here. So I1. And then we have to define our mutation functions. So let's just get back it here and use edit here and function. Y would be mutation, and we have just 1x here. So it will be n. At first we have to determine the number of variables. It would be nominal x. And we just randomly selected one of these variables, so we can use a rand perm here. So j would be rand perm or rand sample, and 1, it means that we just selected one of these variables here randomly. So we want to just change j index, so we have to use this equation here. Y would be equal x, and yj would be 1 minus xj. So just save it. This is our mutation functions here, and we want to apply this code here. So for the pop c, for the pop m I dot position, we have the mutation operators. We just use pop I1, which is selected for the mutation. So it is its index would be I1. And that position, just save it, and I will just wanted to check that First of all, we just here, this is our pop m, which is defined as a pop for mutation, and then we have this loop for a mutation. We just randomly selected an index from pop, and then we have this pop. So let's just get back to codes. So here we just this is just inputs for mutation, and the j is selected, so the index is selected at 5. So here we have an input x, and index 5 is 1 for so for j the index 5 would be 0. So as you can see, this is for j and index 5 is 0. So the mutation has been applied to our input. Just save it, and we have to add a comment here. So after applying mutation, we have to evaluate our cost function here. So pop m I. So after applying mutation, we have to evaluate this position here. So we have a pop mi dot cost would be cost function, and just copy this position here into our cost function. So just evaluate. So this is the end of our code. So let's just go to the next session.